Hi students, in this class we will learn about force on a current carrying conductor in a magnetic field. To understand magnetic force, you look at this diagram. You can see an aluminum rod. This is the current carrying conductor, say aluminum rod. This is suspended horizontally from this stand. The end A of this conductor is connected to the negative terminal of the battery and end B of this conductor is connected to the positive terminal of the battery. This is the current carrying conductor. Place a horseshoe magnet such that the conductor lies between the two poles of the magnet. This is the north pole and this is south pole. We have already learned in part 2 that a current carrying conductor produces a magnetic field around it. This magnetic field will exert a force on this horseshoe magnet because this horseshoe magnet is placed in the vicinity of this current carrying conductor. But we know this horseshoe magnet is a magnet. Therefore, the magnetic field of this horseshoe magnet will also exert an equal and opposite force on this conductor. How will you draw the magnetic lines of force for this horseshoe magnet? From the north pole to the south pole. We know the electric current flows from the positive terminal of a battery to the negative terminal. In this diagram, the electric current flows from B to A. When the electric current flows from B to A, the force on this conductor will displace it towards left. But if you reverse the polarity of this battery, that means if this is positive terminal and this is negative, in that case electric current starts flowing in this direction. The electric current flows from A to B. In that case, you can observe the displacement of this aluminum rod is towards the right. That is, the force exerted on the current carrying conductor depends upon the direction of current. How will you draw the magnetic field lines of this horseshoe magnet? It is from north to south. If you interchange the poles of this horseshoe magnet, that means this horseshoe magnet, north pole becomes south pole and south pole becomes north pole. Place the magnet such that this end is the north pole and this end is the south pole. In that case, the magnetic field lines will be in this direction. When the magnetic field is reversed, the force on this conductor also gets reversed. The force exerted on the current carrying conductor depends upon the direction of the magnetic field acting on it. We understood that the magnetic field exerts a force on a current carrying conductor. The force exerted on the current carrying conductor depends upon the direction of current and the direction of the magnetic field acting on it. It is also found that this displacement of the rod or the magnetic force on it is largest when the direction of the current is at right angle to the direction of the magnetic field. Please note that this magnetic force is largest when the direction of the current is at right angle to the direction of the magnetic field. We understood the force on a current carrying conductor depends on the current and the magnetic field. Fleming's left-hand rule is a simple rule to find out the direction of the force on the current carrying conductor. According to this Fleming's left-hand rule, you stretch your left hand such that the thumb, the point finger, and the middle finger are mutually perpendicular to each other. The point finger represents the direction of the magnetic field. The middle finger represents the direction of the current. Then the thumb will give you the direction of the force on the conductor. In this class, we learn about the force on a current carrying conductor. When electric current passes through a conductor, a magnetic field is produced around it. If this is placed in the vicinity of another magnet, the magnetic field will exert a force on this current carrying conductor. The force exerted on the current carrying conductor depends upon the direction of the current and the direction of the magnetic field acting on it. Also, please note that the magnetic force is largest when the direction of the current is at right angles to the direction of the magnetic field. We also learn Fleming's left-hand rule. It is used to find the direction of the force on the current carrying conductor. Hope you understood this session. See you in the next class.